All right, here is question 9a. For the vector that's given, so we have this relationship, right? X sub t plus 1, the next iteration, the next time step, is equal to the matrix 1, 2, 5, 4 times x sub t. And this is matrix A. So the first question is, are there any equilibrium vectors? Meaning, are there any vectors such that the matrix times the vector is equal to the vector? So that x equals a times x. Just like an equilibrium, right? So the question we're trying to solve is there a vector where you have the vector equal to a times the vector? Well, let's find out. So this is equal to 1x1 plus 2x2. And this is equal to 5x1 plus 4x2. So let's see, I have the equation x1 equal to 1x1 plus 2x2. So x1 equals x1 plus 2x2. The x1's cancel and you get x2 equal to 0. Okay, and then in the second equation you have x2 equal to 5x1 plus 4x2. But x2 is 0, so we're left with 0 equals 5x1, which means x1 is also equal to 0. And so what's happening here is that another way you can think of this, right, so I should say, all right, our equilibrium vector is, the only answer is 0, 0. And what's really happening here is because this matrix happens to be invertible, the only solution to this equation is 0, 0. Another way you can think of this is if you were to subtract this over and say you want to solve 0, 0 is equal to, you know, this minus, right, you could say, right, this is, you know, the identity matrix times x1, x2, then if you do this one minus that one, or the other way, 1 minus 1 is 0, 2 minus 0, 5 minus 0, 4 minus 1. Right, but since this matrix is also invertible, then you would have that x1, x2 equals the inverse of this matrix. Let's call this B. So then it would be B inverse times 0, 0. But any matrix times 0, 0 is going to give you 0, 0. So since this matrix is invertible, the only solution is 0, 0. And that's typically true. All right. I'm going to stop this one here. I'm going to do all the parts individually.